right. All right. Hi, everybody. Thanks for coming. Happy Tuesday. Welcome to week 5. We are so last week was more of a catch-up week. We didn't have any real assignments due other than the homework. Hopefully you've started on the homework. If I don't know if you can go to, let me open Canvas. I don't know if you're able to see. Yeah, so you should be able to see the People tab. So you go to the People tab and then Groups. Yeah, so if you're, because homework 1 is you're working in with partners. Yeah. Homework 1, you're working with partners. Because no one's joined a group yet. So if you've got your partner or partners that you're working with homework 1 on, join a group on Canvas, and that way that makes sure that when someone submits work for that assignment, then all of you will get credit for it. Question. How many people per group? Yeah, I think up to 3. That's true. However, this is an academic environment. Okay. All right. If you've got questions about that, maybe I'm gonna try having the work time in the middle of the class. So we'll get back to this later. I'm gonna bring us all back. Bring us all back, please. The other thing to announce, I apologize on my part. I didn't realize that this was something that's already built in. There are STEM Center tutors for this class, so if you are interested in that, they are available. And the way that I found that out. Okay, Jason, Julio, great. Yeah, so the way I found this out is if you Google St. Mary's STEM Center, that takes you to a page like this. And we scroll down to computer science tutoring schedule. And then you can see here's the people who can tutor different computer science classes. Some people have 222 next to their name. That's us. So if you're available, go to a time when they're there. And yeah. Okay. The other note is that the dean of the School of Science is hiring some students this year and next year for planetary field experiences. So the areas that would probably be most aligned with computer science would be like robotics and instrument development. If you're interested in that, you can go to the info session on October 7th and apply for that. So just wanted to make sure you're aware that that's going on. Any other announcements, questions, concerns?
We should go back to pen, like pencil and paper, like not use Canvas anymore, to be honest.
I like Canvas.
Canvas hasn't been treating me very well, that's why I have this like negative.
That's fair.
Have you used Moodle?
I used Moodle when I was here, and I like Canvas better.
I liked it back when it was just like you're on a sheet in the desk somewhere.
Yeah, it depends. All right, any questions, comments, concerns on any logistic things or any course material? All right, so let's get going. So first off, we're going to review our terminology. Let me open the correct PowerPoint. Maybe. Okay, so I need to use the slideshow. So remember we were talking about classes last week. So we write the .java file, that's a class. So it says public class, then the name of the class, right? So that file, that's a class. And that is the sort of structure that we have is up in the air. It's more like an idea. And then once we actually say like combo lock C equals new combo lock, now we've created an object. We have instantiated the class. And so, yeah, so we've got an object or an instance of that class. So the class is kind of up in the air idea. The object or instance is the actual tangible thing that we can work with. A member of the class is typically like constructors, fields, or methods. Fields are the variables that belong to a class. Methods are things that do something. So those are the functions. Public or private is visibility options for anything in the class. Constructors are how we actually make an object. So when we say new combo lock, we have to have a constructor to set up any fields or something in our class. The toString is a special method. If we name it literally toString with a capital S, then we can call like print variable. And if that class has the toString method implemented, then it'll print the state of whatever we return in toString. So toString is a special method. We looked at a bit at equals. So equals lets us know if one object is equal to another. And I think that's all the terminology I want to go over now. Any questions on this or any other ones? Okay, so hopefully this syntax should be becoming more familiar to you by now. If you're still confused on things, send me an email, come to office hours, ask me questions. Okay. That's my terminology review. I'm so sad at myself. I did not bring my drawing pad. So the pictures are going to be bad today, but we're still going to draw pictures. Okay, so yeah, so just so you know, so we're going to draw pictures a little bit. We're going to talk about inheritance. We talked a little bit about it last time. We're going to go in more detail today. We're going to implement, here's what it looks like to inherit something, test it out a little bit. Then we're going to talk about what we did, what does it mean, some things that we have to talk around that. Then we're going to try and have a break in the middle today, and then we'll get to hopefully abstract classes and maybe interfaces. That's our plan for the day. So last time we talked a little bit about inheritance, where we talked about how inheritance lets us reuse some code and extend functionality of the code that we write. It helps it to be a little bit easier to maintain and update our code in a way that's kind of unique to object-oriented style programming. So we're going to talk about the different relationships that classes can have to each other. So our motivating example last time was the person class, where we have a class person. We have a class person, and we've got a constructor, maybe two constructors, and then just setters and getters for our fields, which are just the person's name, their age, address, and phone number, right? So simple class. But we want to make a student class, and we want student to have all these same pieces of information. We want a student to have name, age, address, and phone, because a student is still a person. Person should have these pieces of information associated with them. but we also want the student to have GPA. And so the bad way to do this is to copy and paste everything in this class and then add like private double GPA. That's an option. We don't want to do that. So we don't want to do that for student because Java has a way to represent that relationship. So we're going to talk about the relationships with the term is A and is not A. So let's kind of see how this works. This is not going to be pretty. Can I do text? No, I can't. Okay. I'm so sad that I didn't do this. Okay, so we've got person, and we also have student. And so we can represent the is a relationship by like drawing a line between person and student. And so having person above student. And so this tells me that student is a person and we're going to inherit. So kind of like a family tree, you know? Like if you're a child and there's a parent above you in the family tree, the child inherits some things from their parents. So similarly, student is going to inherit things from person. We're also going to have, we'll look at an example of shapes where we can say like, make the text bigger as I go. Circle, rectangle, square, what are your other favorite shapes?
Big octagon. Yeah.
Octagon. Okay, so if we were going to arrange these shapes in a family tree, what should it look like? What's on top? So I think shape should be on top, right? Because shape is like the most general. And then going back to like high school geometry or something, let's go look between rectangle and square. What should be above? Rectangle, right? Because a rectangle, sorry, a square is a rectangle, but a rectangle is not always a square. So of those two, rectangle is the more general. Circle and oval, probably oval. Octagon is kind of off on its own. If we had, maybe we had like n-gon or something, and then octagon would be below that. So now if we draw our lines, is too big? That's a little bit too big. That's okay. So now we have this notion of an oval is a shape. A circle is an oval. A square is a rectangle. A rectangle is a shape. So we can say that is a relationship holds going upwards, right? Because we can't say a rectangle is a square. That's not always true. Let's see, what are the other examples I want to look at? Let's do cars. So let's say we had so if we look at cars, we can have like vehicles, we can have maybe a Tesla. Could have a tractor. So how would we organize our car family tree? What goes on top? Vehicle? Yeah, because I would think, because you can't really say a tractor is a car, right? But a tractor is certainly a vehicle. And so then a Tesla is a type of car. So we can say, and we can say like a Tesla is not a tractor. I don't know if you bring in the Cybertruck, maybe, but like a Tesla is not a tractor. There are two different kinds of vehicles, and you can say that these are not the same. So we can say like a tractor is not a car. Okay. We can draw this sort of family tree for a lot of different types of things. So one example that someone in the class the last time I taught this is like beverages. We could say like maybe break it into like cold and hot beverages, and then like water, you could have a soft drink, sparkling water, and break it down from there into like brands and types of things that you can actually sell. And so talking about like the more general type things, we want to have a way to represent that in code. We're going to do that with abstract classes, but we'll talk about that later, hopefully today. All right. Okay, so we kind of talked about this last time where when we have the person class, if we want to make the student or employee class from there, we're going to do this inheritance that Java allows for, where we want these classes to have a relationship where we can say a student is a person and not have to retype all of that code. So in order to actually do that, we are going to use the, where did that go? I've lost the slide. That's okay. So we're going to extend the class person. So I'm going to make a new Java file. And I'm going to make it student. And I want it to live in the people package. This is another ding for VS Code. In Eclipse, I can say, here's the superclass, but to my knowledge, Eclipse or VS Code doesn't have an editor for that. If you find it, let me know. But for now, we have to type it manually. So we're going to have a class student that extends person. And so that's us when we have that diagram of person, line, student. That lets us say that student is inheriting things from person. So we have to say student extends person. The key is that person, capital P, P-E-R-S-O-N, is a person.java file that's defined in our workspace. So we know where this file lives. And so that's why we can say student extends person. And so from here, we just want to, all we want to do is we want to add the GPA as a field. We want to add the getters and setters for that and change the constructor a little bit. So we're going to say we have a private double field, GPA. And we're going to have a constructor. So let me see if I can do that. I can. Awesome. So when I click to generate constructors, it shows up as hey, person has constructors. Do you want to imitate the behavior of those? Which, yes, I would really like to do that. So we defined two constructors in person. One with it, I think there's name, age, address, and phone, and then a 0 parameter constructor. So I'll take those two. I think I missed a step. Hold on. Fourth action. So both of these, oh yeah, I missed that. And I would like to, I'll see what it does when I give it the double. And there we go. So that's pretty much exactly what I want. So now it has a constructor for student. So those two boxes that I checked, they said person before. Now the actual constructor in this class says student. So when we are extending a class, we need to have, in that extended class, we need our own constructors. So student needs its own constructor. And then we just set GPA as equal to GPA. We've got aligned to super. And so we have aligned to super because it's calling the constructor from the super class. So in terms of terminology, I'll go back to the code in a second. Where terminology? Yeah, so there's the notion of a subclass and a superclass, a base class and a derived class. So we go back to our drawing here. So person is the base class or the superclass. And student is the derived class or the subclass. In terms of terminology, that's what we talk about. So we've got person, that's the base class. That's like the one that we start from. And then from there, we derive student. We've got student, that's the subclass, and person is the superclass, the level above. And so when we have a call to super, that's calling the constructor the level above in person to say, you've got this constructor behavior for the following fields. So you've got constructor behavior for the name, the age, the address, and phone. That's already defined in this constructor, right? So don't do work, like don't double the work that we have to do. Just call that constructor, which we do in this line. And then we just add, here's what you do with this new field, GPA. Question?
Your public student extends person doesn't work, and I have to put in the parameters for person into the student class.
That should not be the case. Do they live in the same package?
Yeah, sample.
At the break, I'll come over and see what's up. Is anyone else having that problem? Okay. All right, so we've got our constructor, and so here I actually don't want, I could take just double GPA. But I actually want a 0 parameter constructor. And so I will say, so for my 0 parameter constructor, this works because in person has a 0 parameter constructor. So I can just say super that with no arguments. It's kind of like when we use this to call a constructor for like combo lock.
Super always refers to the extended class.
Yes. Yeah, so when we have A extends B, super will call the constructor for B.
And it'll point it to the same object as the student that we're creating.
Yeah.
Oh.
Yeah, so the thing with this is that, where is that slide? So when we extend person, we can add new fields. So like we can add GPA, that's a new field now. We can add new methods. So we can add like a get and set GPA. So if I want to do source action and generate getters and setters, then it has get GPA and set GPA. So those are new methods that I've added to my student class. And that's all perfectly legal. We can also, so we can override existing methods. We'll see that in a second. But the thing to know is that even though like name, age, they're private in person, we still have them in student. We can't directly access them, but they still exist. We can't remove any fields that were defined in the superclass. So we couldn't say, I'm a student now, I don't need an address or I don't need a phone number. I can't just decide no more of this field. Those fields are inherited. We can't remove them. And similarly, like we can't remove, like we can't decide to not set the name. We have to have the set name method inherited. So we can't decide to delete it. We can also override existing methods. So did we have a toString here? I did not. Let's add toString in person. So I have public string toString and then just the default one. That's fine for now. And then in students, right click, source action, generate toString. And you see there's some options here. So I can say, I want to include the GPA. I can also include like the name and age. So maybe I want the name and GPA. So now I have the same method name in both person and student, right? Person's got toString, student's got toString. So when I do something with student, it's going to use the updated method. So in this case, I have overridden the toString method. So you can see it adds the little tag at override. So I've like overwritten it to say, you're not going to use that old method, you're going to use the new method. And this is what you're going to do. So let's test it out a little bit. So I'm going to make a new file, person demo. And just a main, just to test things out. Okay, so let's say you can put your name here if you want. Let's just put some numbers here. Let's say I live on 123 Main Street. And my phone is 123-456-7890. So now I have a person object called Sarah. If I say to print this object, it's going to print the information for a person, right? Because this object is of type person. And so when we do that, we see it prints the information for a person. Great. Let's say mm, let's say, I don't know, let's say student Sarah has an amazing GPA. Okay, so if I create a student object and give it pretty much the same information, right? So it's still got the name, the age, the address, the phone number. It just has an additional field that we added the constructor of the GPA. So instantiating it, pretty much the same process. If I print this object, let's say I don't have this. If I print this object, what's it going to give me? GPA. Well, if I don't have a toString method in student. There's no toString method in student, and I print this student object. Who thinks the student should know what to print? Who thinks the student doesn't know what to print? Okay. Turns out it does know what to print because it inherits the toString from person. So if we don't have it, if we did not override it in student, then it inherits and says, oh, I know what toString does. I got that from person. And so it'll print the information for a person. It prints student Sarah just because that's the name in the string that I gave it. But if I do have toString method, and then I print the student, now it prints information for a student, right? So the toString method was overridden when I said, I'm going to define this method in the student class. Okay, questions so far? Okay, so we can override existing methods. We have to specify our own constructors. So if you extend a class and you get an error, and that you're probably going to get an error that you don't have your own constructor. So make sure that you have that. Other things that we have to talk about. So if a field is private in person, we cannot directly access it in student. So we can't say, if we didn't say get name, we can't say name. If we try just saying name in student, we're gonna get an error saying the field person.name is not visible. The reason for that is back in person, we said name is private. That means we cannot say like p.name anywhere other than person.java. But it doesn't mean that it's not accessible. because so the way to get around this is using getters, because we can say get name, and that gets the name for this object. So we can say get name. If we want to be really sure about it, we could say this dot get name. Either works. If you are running into issues, maybe include this just to be sure. But that's, yeah. So yeah, so private doesn't mean that they're not present. So a student object still has an address, an age, a phone number, and a name. So a student still has that information. So we saw this when toString is not defined. So if the base class methods are not specified in the derived class, so if we have something in person that we don't say again in student, then it just inherits them unchanged. So like if we didn't have toString in our student class, it would just print the toString that was in person. But if we do declare it, then it gets overwritten. So the one in person no longer applies. We're going to go with the one that we say in student. We can't reduce visibility when we're overwriting things. So if it's a public method, we cannot say, now this is a private method. That's not allowed. We can only increase visibility. So we cannot decrease visibility. And we can add additional methods in our derived class. So like we can add get and set GPA. Those are things that person didn't know or care about, but we can add them in student. So yeah, to extend that functionality. Okay, so now we're going to play around with type compatibility. So I want to write, I'm going to write this method pretty much exactly of telling whether one person is older than another person. So we're going to say over in person demo, public static Boolean is older. And then its two parameters are person P1 and person P2. And we are going to return P1.getAge. Age is a method that belongs to a person. And we're going to return whether P1 is older than person 2. If P1 is older, then we're going to return true. If they are, if person 2 is older, then we'd return false. If they're the same age, we would also return false. Right? Question.
Did we keep everything else that was in the person demo as like ingredients, or did we just?
I added a new method. So main is a method. I added a new method called isOlder. Yeah, okay. And so because of that, I don't know, let's make student Sarah 18. And then if we call our isOlder method we should be true because 25 is greater than 18, right? And so this works. Right? So we get an answer. Is Sarah older than student? True. So talk with your neighbor for 30 seconds. Sarah and student are two different types. They're person and they're student. This works for person and person. Talk to your neighbors. Why do you think this works? All right, so why do you think? What's going on here? Any ideas? Yeah, Juliana. Yeah. Yeah, this is where that is a relationship comes into play. A student is a person. And so that in that way, we can refer to a student as a person. The only caveat being that we have to work with like exclusively person methods. So we can't say like get GPA or something like that. Like we can't do that because a person doesn't know what a GPA is. Only a student knows what a GPA is. So we have to work with more general methods and things because those are things that person knows what to do with. And so this is what we call type compatibility. So a student is a person. So we can access a student object by a person reference. And so it makes it more generic. And this allows us to access this like get age method instead of the very tedious like option for like person P1, student S1, person P1, you know, like at making instead of person, maybe the tedious way would be to have like every single combination. If any of you are in the discrete math, like every permutation of person, student, employee. And it prevents us from having to add more if we add like another type later into this hierarchy. So this is our caveat on type compatibility. So this is allowed and encouraged. I have this slide and every time I just skip over it. Yeah, so the reason that this works is because of this thing called dynamic dispatch and polymorphism. Basically, a derived class is type compatible with its base class. So student is type compatible with person. So we can go up, we can't go the other way. So person is not type compatible with student because a person wouldn't know what's GPA. If we have an employee class with like salary, a person doesn't know what a salary is. An employee doesn't know what a GPA is. So you can see kind of how these interact, where that's where the whole is a and is not a relationship comes into play. If you want to learn more about that, there's dynamic dispatch, late binding. There's all different types of bindings that languages do this a little bit differently, but that's kind of out of the scope for this class. Let's look at instance of. So let's say, okay, the other thing with type compatibility lets me do something like this. So I can make an array that holds these two objects, as long as I make it a person array. So as long as I go up a level and make it more general, I can have an array of a person and a student. And so let's say person PER in my array P. Let's say if I want to go through this array, and if this person is a student, I want to print their GPA. So I can do that with the instance of operator. So I can say if the person is an instance of a student, then I can print their GPA. I'm currently getting an error though. Why is that? So what is the error exactly? The method GPA get GPA is undefined for this type, for the type person. Remember all the way back when in the beginning? Did you have, was that a hand? Okay. All the way back in the beginning, we talked about the fact that Java limits implicit typecasting. Those are the magic 4 words that are why this is happening. So person, we've said, or PER has type person. We are trying to call getGPA. GetGPA is a method that belongs to a student. And a person is not a student, not necessarily. And so what's happening here, we are implicitly trying to typecast person to student. To say, PER, you're actually a student and I want to get the GPA. But we can't do that implicitly. We have to do it explicitly. And so we have to, we're probably going to have to add some parentheses here. So if I have parentheses around the variable PER, and then have a set of parentheses beforehand, now I'm saying I'm casting per to be a student. And we know that this is going to work because I have said if per is an instance of student. So if we've gotten to this if to the block of code after the condition passed, we are sure that the variable is a student. And so we cast it to be a student, and then we can get the GPA. So we have to explicitly cast the PER variable to be a student. Okay, let's say maybe otherwise we can print the name. Okay, so when we do that, we should get what? If we've got my person object first, do we print the name first or the GPA first? Name? Right, yeah. Because the person object goes first, that'll hit this, and then the student object, which will hit this. So if we run this, then we get Sarah, then we get the GPA. Okay, so the moral of the story of here, instance of works if you need to say is what type this is. Yeah, so we talked a little bit about visibility. So private members in the base class, so like the name and age in person, they're not directly accessible to student. If we wanted a student to have direct access to those fields, so we can say like this dot name, we can change the visibility of the original fields. That's an option. So like make it public or package visible. There's also another option called protected. Protected makes it directly accessible to not only anything that derives it, but also everything in the same package. So protected is package visible plus. So that means like if, let's say over in here, I have a protected variable, anything in that package can access it. Let's say I have a derived class over here. This derived class can also directly access it. So that's another option, is to make it protected. I don't know. I think that getter and setter methods should probably be okay for working with this. If I think this is extremely project dependent. So it depends on how you are doing your project management, and do you want to directly access this field, or is a getter and setter okay? All right, so this is our visibility summary. So now we've talked about subclass here. So we kind of know what subclass is about now. So like if something is public, can we access it in the subclass? Yes. If something is protected, can we directly access it in the subclass? Yes. If it's package visible, and the subclass is in the same package, then yes. But if it's package visible and the subclass is in a different package, no. And then private is only accessible within that one file and then not anywhere else. So I think we already talked about this. So each derived class should have its own constructor. So student has to have its own constructor. If we made a new class employee, that needs to have its own constructor. Yeah, so it first constructs the inherited person. And so the super call, we have that's got to be the first line of the constructor. So let's see if we moved. Okay, so here we've got the super call to super and this dot GPA equals GPA. If we swap those, we've got an error. So the call to the super constructor has to be first. So this has to be first, otherwise you're going to get an error. So it constructs the inherited portion first. Yeah, if you don't provide it at all, then it just does some automatic constructor, like if you didn't have a constructor at all. I don't know that I want to do employee at the moment. Yeah, so there's other options we can do. We can have a final keyword where we can say the buck stops here. So like you can have a final class, which means that you cannot further extend this class. So like this is as specific as we want this to get. We can't extend this class at all. Similarly, for a method, you can have a final method that's not overridden at all. I don't know why I have this here. I apologize. Yeah, I don't know what I was thinking. Yeah, so we would want to make a method final so that it could be invariant, to where it's always going to be defined like this, and it's not going to change. So sometimes that's helpful. Yeah, so if we have a final class, then that class cannot be extended. We can also call it a leaf class, if you're familiar with trees at all. If not, we'll look at them later this semester. Note that if we have a class that has all the methods are final, that doesn't mean that the class itself is final. So unless we say, like, unless we say like final class student extends person, the class won't be final itself. We could have like, we could have a final get GPA method, and that way no one could override our get GPA method. But even if all of our methods are final, that doesn't mean the class itself is final unless we put it up in the class signature. Trivial setters and getters are probably good candidates for final methods, just because that way we'll always know that get name will just return the name field. Yeah, so we talked about we can't reduce visibility. We can also do partial overriding. Let me see. Oh, how much more do we have? Not that much. Okay, I think I do want to show you this. So I'm going to let me make a package called worker. And I'm going to make a file worker.java. And this class is going to have just a really simple method. A method called do work. And it just prints the word working. So our worker is working. I'm going to make another file, workaholic.java. And it's a class workaholic, which extends worker. And we're going to do partial overriding. And so we're going to have the same method name. So we're going to say public void do work. And what we're going to do is we're going to call the original method. So we're going to say super dot do work. And then maybe we have a method that's just empty, but drink coffee. So maybe we can say drink coffee and then do more work. So in this case, it's going to, if we would call this, we would have working printed, then we would drink coffee, and then we would do more work again. So we are doing so we're partially overriding the do work method, where we're doing things a little bit on our own terms, but we're also calling, here's what the original method did. So we're calling this method when we say super dot do work. So this is partial overriding, where we're doing what the base class does and a little bit more. Yeah, question. All good? Okay. So that's partial overriding. So we looked at having a bunch of people in an array. Do you have a question?
Yeah, and so for the drink coffee portion, that's the one that we're adding.
Yeah. Yeah. So we're adding drink coffee and we're also adding like do work twice. So not only are we calling super.do work and drinking coffee, then we're calling it again. So it's doing like double the amount of work. Yeah. So let's say we have a person array and we said this person array is going to be full of employees, and then we set the first thing in that array to be a student. That it wouldn't work. That would be a problem. So we have to be careful if you're working with a lot of subclasses, you have to be careful of and try and make the array that you store them in more general. So you have to like look a level up of what type do all of these share. And this is a whole thing like basically saying if you've got a method in like an hourly employee class and a salaried employee class, and you are returning something, you have to make sure that those return types are compatible. So we call that covariant return types. Basically, just be careful when you're doing operations with the class hierarchy. Make sure that the return types and all the things that you're working with are compatible. Okay, so I'm gonna give maybe 10 minutes break or so, and then hopefully we'll have some time to look at abstract classes. So I'll pause the recording and then we'll come back in like 10 minutes. All right, so we've talked a little bit about just inheritance in general. So we've looked at person, student. Now remember when we looked at the where we had like shapes, where we've got, I want to go back to that slide. Where we've got a shape and we've got an oval, a circle, a rectangle, a square, where we have this hierarchy. The issue with this is that like shape is kind of general, right? So let's say for the purposes of class, we're gonna make a shape and we want a shape to have like an area and a perimeter. Let me see if I can copy this and bring it down here. Okay, so now we have it for later. Okay, so our goal is to define this class hierarchy for shapes. And so I'm going to make a terrible example. And so first what I want to do, let me create a package called shapes. And I'm going to make a badshape.java file. So I'm making it a bad shape. Yeah, question. Yes. Yeah. Everything okay back there?
Yes, so I'm watching the videos.
No, we're working on, we're using Java to do like.
Yeah, we were trying to figure out what's up with drink coffee. I just had to type it on.
Yeah.
Oh, okay. That would do it. Okay, so we're gonna have a bad shape. And let's say that we want our shape to be able to, let's say we want to have a public, if we want a method called area, we'll probably want to make it return a double. And since we don't know what the area of a general shape is going to look like, maybe we just have a placeholder. So maybe we just say return -1. And the idea is that if we get a -1, then we'll know, hey, I forgot to override the area method. And similarly, I can say if I want a perimeter method, then I can say return -1.0 to have a placeholder for anything that overrides or anything that extends this class should override these methods. This is the bad way of doing it. So return having this class that we've got these methods, it could work, but some of the things that we risk by doing this is we risk that we forget to override it. Because remember, when we are extending a class, the methods in the base class are inherited unchanged unless we override it. So we're not technically required to override it. We could just leave it be and then we just have -1 area. The other issue is that for the shape class, we don't necessarily want a shape object, right? It's too general. That's the main problem. We can create a rectangle object or a circle object, but we don't want a shape object because what does that mean? There's no defining features of a shape. The only reason that we want a shape class is so that we can kind of hold this whole hierarchy together. So shape is like the root of this tree where from there we get ovals and circles and rectangles and octagons and so on. So shape is the thing holding this all together. The solution to this is what we call an abstract class, an abstract methods. And so abstract methods are placeholder methods saying, I want this method, I want to have a method called area, and I want anything that inherits this class to override it. So I don't want to provide any default implementation. The shape is I'm totally hands off. I want anything more specific to actually define that for me. And so it requires all derived classes to implement it eventually. And so the idea is that if the subclass doesn't define the implementation for area, then it's going to be abstract itself. So yeah, so abstract method is basically a placeholder method. And so there's no default implementation. And when we have an abstract method, that means that the class it belongs in is abstract. Because if you think about it, let's say we have a shape class and it's got an abstract method, area, and perimeter. We are never going to want to create an object of type shape because it's got methods that don't do anything, right? If there's no implementation there, we're never going to want to create a shape object because we've got missing functionality. It's like an object, but there's pieces taken out of it and it's not fully put together. So we're not going to be able to create a shape object when we've got a class with abstract methods. We cannot create an object of that type. So let's make shape abstract. So let's make a new class that's actually a good shape. So I'm just going to call shape.java. Yeah, question.
So the folder in source.
Yeah, it's just in source. Yeah.
So when you I don't know if you get identify, right, the package.
Mm-hmm.
So wouldn't you just do shape? Because for me, it's just shapes isn't working.
Are you sure that it lives just in source and not in a sub package?
Like in the CS222, like some class and like source. And then I have another folder. That's true.
Okay, let me look at it afterwards. Yeah, okay, so we're going to have some placeholder methods here. So I'm going to say that it's placeholder by using the word abstract. So I'm going to have public abstract double area, close, open and close parentheses, and then semicolon. This is said, this is the method that I want a subclass to implement eventually. I'm not providing any default implementation with it. It's just an abstract method. You may notice we currently have an error. So it says the abstract method area in the type shape can only be defined by an abstract class. So if we have an abstract method, the class it's in must be abstract. So let's see. The options are to either make the area method non-abstract, which we don't want, or make shape abstract, which we do want. And so that just adds now, instead of public class shape, we've got public abstract class shape. So any class that's got abstract methods has to be abstract itself. So then we'll have our method perimeter, which is also abstract because a shape doesn't know what it means to have a perimeter. It's too general. The only method that we can provide default implementation for is going to be semi-perimeter, because like if perimeter is general, we also will always know what semi-perimeter is as long as we know what perimeter is, right? Because semi-perimeter is just that divided by 2. So we can say that this is a final method because the definition of semi-perimeter is never going to change. So here we can have implementation, and in fact, it's going to be final. And we're going to just return the perimeter divided by 2. That's always going to be the case for semi-perimeter. Yeah. Sounds good so far? So abstract, kind of like the name says, it's kind of up in the sky. We don't know what a shape is. Similarly, there's an example in is this it? I think so. So lab 4 is using inheritance and using abstract classes. And there's also an interface, which we'll get to what interfaces are. But we're going to have an abstract class called employee. But the issue is that employee is so general. We want to have more specific types of employee. And those types are like salaried employee and temporary employee and a staff. And so we break these down into types of employees. So you've got your salary employee and your hourly employee. Hourly employee itself is too general because this company has both staff and temp employees. And so hourly employee itself is going to be abstract until we get to the most specific examples for staff and temporary. And so, yeah, where was I going with that? Yeah, so we cannot create an employee object. That's too general. And it's got abstract methods. Hourly employee is too general. And so the things here is, we've got this whole big diagram. So the way that we read it is the top half here, we've got ID, first name, last name, and title. Those are fields. So the red box, those are fields. And then we've got employee ID, first name, last name, title. That's the constructor, right? And then we've got our getter methods to get the ID, get the first name, get the last name, name, title, net pay. And then we've got two abstract methods. And so as you read through the instructions, read through it very carefully. So let's see the instructions here. So you'll see, like, here's what their salary is, like their net pay and their taxes. So like staff are 15% tax rate. Temporary, we don't take taxes from their gross pay. So where's so they get gross pay and get taxes. That all depends on the more specific type of employee. So an employee themselves, they're abstract. And so, yeah, so in our case, for hourly employee, the get gross pay is defined there. Get taxes, because that depends on the type of employee that you are. So the taxes is going to be defined in either temporary or in staff, pertaining to the actual requirements. And similarly for salary employee, we're defining all of the gross pay, taxes, and net pay, so that because we're defining what those methods look like, salary employee is not abstract. Does that make sense so far? Let's kind of look at the code. That looks weird. Let's try that again. Okay. Source, main. This lab is tricky, but once you get it, it really helps you to understand what are abstract classes, what are abstract methods, how do interfaces work, which we'll talk about on Thursday. So yeah, so the code that you're given, it should be pretty much empty. So your job is to fill it in. And so you're given this diagram. Let's go back to the diagram. So now that I've told you how to read it, so like all of this, the normal text, that's all implemented there. The italics is abstract methods. And so your job is to go through and actually implement these classes. Okay, so that's the lab so far. Okay, perfect. So just to kind of summarize, so the types of methods that belong in a class. So first of all, we've got normal methods where we can define them in a class and then we can extend that class and they get inherited unless we override it, right? We've got final methods where this implementation is invariant, will not change over the entire inheritance hierarchy. So for our shapes, I think next time we'll look more at like, I'll add like rectangle, circle, stuff like that. But for our shape, the semi-perimeter is not going to change. We can't override it. And it also doesn't make sense to override it because semi-perimeter will always be that over 2. Abstract methods are when the base class doesn't provide any implementation. It just has a method signature So remember, the method signature is like the visibility modifier. We've said it's abstract, that means it's a placeholder. And the rest of the signature is the return type, the method name, and any parameters in the parentheses. So this is basically the method signature. Yeah. Right. So next time we'll make a rectangle extend shape, and then the rectangle must implement area and perimeter, or rectangle will be forced to be abstract itself. Remember, we've got static methods. Static methods mean that we do not have a controlling object. So that's why most of our tester classes have static methods, because we're not going to make a tester object. We're just going to call the methods. And then there's the other category is everything else. Okay, any questions? Okay, if this is super confusing to you, you're probably not alone. So I would start to work on lab 4. You're gonna get tripped up in interfaces, but you should have all the tools to work on the rest of it. So find a partner, work together, run into problems, ask me questions. So yeah, questions? Oh, the active learning. Yeah, we did a lot today, didn't we? Turn in shape.java. Let me edit that. Today's the 24th. All right. Thanks for coming. See you on Thursday. Start work. Shape.java. Work on the lab. Start the lab. And also the homework.
Oh,